All right, for this, I believe here we go. This says it's a calculus team warm-up. I have no idea if I turned everything on. Yes. The teams are in these rows. And you're playing for 5 points extra credit. 5 points extra credit for the winning team. Listen very carefully. I need all the rear row captains. I need all the rear row captains. Quiet, please. You're not listening, and you won't be able to participate. I need all the rear row captains to walk over to the desk and pick up one pile. In that pile should be letters A, B, C, D, and E. You need to listen. The team that gets the 4 points or 3 points, the highest score, wins. You sit down once you have all your pieces of paper, A, B, C, D, and E. There's no talking, and obviously I am mic'd up today, so I can always go back to the tape and say, yes, you did talk. There's no talking in this drill, okay? I like to use the word drill, makes me remind me when I was coaching. All right, there's no talking in this drill. It's very easy. The person in the back works out the problem along with everybody else in the row. When the person in the back thinks they have the answer, they pass it to the person in front of them. If the person agrees with that answer, they pass it to the person in front of them. If that person agrees, it passes to the front, passes to the front. The person that holds up the correct answer first, their row wins 1 point. Now, if your row wins, it has the most points at the end, I'll give everybody in that row 5 extra credit points. That's a big deal. That's 5% on your next test, easy. Now, if there's a tie, I'll give both rows 5 points extra credit.
Wait. So if no one did anything, we would all get 5 points?
No, because one person, one row will do it for 5 points. And
not do it, and everybody can get one.
You could stick around that, but you know Orrin is going to be the type to, I'm doing it, 5 points, here you go.
But if everyone would get 5 points?
Now, if Wes or somebody passes it up and they think it's wrong, without talking, they have to send it back. Or grab another letter, send it up.
So the only person that can change it is
You can hand up your work and the letter if you like.
so who can all change it? Can everybody make her?
Anybody can change it. No, because in the back, quiet please, in the back are 5 pieces of paper that have the letters A, B, C, D, and E. They can only send one letter up. If you send up C, and it gets up here and they say you can't say what the answer is, you have to hand it back. It's a multiple choice question. You hand it back. If it's a numerical question, yeah, you can hand up your work and see if it's right. But these are all multiple choice. So that's why you have the A, B, C, D, and E. The person in the back is the lead, the point man on the problem. They work it out. They send it up. If the person in front of them, no, I like this. So listen very carefully. Let's say, for example, Jake Bach works out a question. He hands it up. Otter doesn't like it. She hands it back. Jake gets frustrated, works again, hands up a different one. Otter says, hands it back. Right now, they're feeling the pressure because obviously Wes's team is already up to Betsy and passing the baton off to the finish. You can't talk. If you talk, your row is out for that question, possibly out for the activity.
So who can give you the final answer?
Final answer comes, no, you give it to me, the last person. You hold it up, I come and get it. You hold it up, I come and get it. Hold it up, I come and get it. They hand it up. I think we'll be fine. All right. Yeah. First one in gets the point if they're correct. Huh? You cannot talk. You can't make any noise. This is all about your ability to work. Oh, yeah, there'll be people that get thrown out. They can't help themselves. Ready? Now, remember, my activity, I plan to do this at least 4 or 5 times before Christmas. Okay? If your row gets thrown out, you'll be placed on probation. You can't cheer. You're cheering against people. This is all designed for one person in the room to get after it. Ready? Now, some of these are going to be quick. Some of these you might not even have to use a pencil. Shane Canfield probably knows the first one, like that. There you go. It was B. Oh, that's wrong. Oh, it's A. What do you got?
Hold up a second. I'm holding this up.
These two tied.
Are you sure yours is right?
Yeah, the conclusion of Rolle's theorem. Who?
Oh, it's not what is. Not ours.
Huh? All right. Yeah. Yeah, Rolle's theorem is when the derivative equals 0. I just saw the mean value theorem right here, and I thought it said mean value theorem because I was worried about people talking. Here's a B. Here's a B. Here's an A. Here's an A. Now, one more rule. If your knees swing out of the chute, Audra, who swing, yeah. Last time you about fell over grabbing it off his desk. He was still reading. I could tell his lips were moving. Yeah. All right. Stand up. Ready? Whoa!
No, that was full.
I think we're wrong.
Yeah, I don't think that's
All right, this was the first one in. Anytime you put a number in for a constant, it's going to equal the constant. It should be 4. There. 4. Hey, Jolie got it right. There's a point. What'd you answer?
Shane answered E.
E?
Yeah.
Jake did C? What'd you go with? What'd you go with? A and A? All right, ready? Yeah. I'm so worried. I don't want to make anybody mad. Who's talking? All right, ready? All right. You guys are supposed to be working out also. Oh, I forgot to give the point to Jolie. You're not working it out either?
No, I'm.
2 different answers.
Here you go.
So it should be C. Should be C. So your answer is incorrect. B, whoever came in second was incorrect. Another B that came in, I think it's over here. Had to be yours. A, C, and who else has C? All right, I'll give you both rows a point. Yeah, but it's clearly Jolie's row went first. 1, and then who's got 2? They tied. Yeah, this one doesn't have any, does it?
Wait, you just gave the second row two.
One. You guys have a point? You do not. You don't have any.
They have one. They have one.
Oh, yeah, the first one.
We have two. They have one and the other person has one.
All right. There you go. Right down to the last one. Right, here we go. Last one coming up. Look at Shane. He has them all spread out nice and neat. Just like playing Monopoly. I like that. Oh, these two. These two tied. Yeah, it is B. Nice job. 2 and 2. Nice job.
So we all three get 5 points?
Yeah. All 3 rows. Yeah, but they were holding him up while it was still coming up. Yeah? No, he held it up. Joey had it up. No, she didn't. That was their row. That was Audrey going, yeah. I will. I'll go back and look. Sure you can. All right. Sure. You got to remind me. Okay? All right, now, take the point. You know what? I just want to give everybody 5. I might do that. Well, if you're in the room. If you're listening to this, you won't get the 5. All right. So go ahead and hand the letters back. Rear row captains, take them, put them back on the table, please. And I got a few problems to do. And we got a brain break in about 10 minutes. Okay? Now, all these problems that are next, yeah? Okay. All these problems next that are coming up are the word problems I just copy and pasted. I did this today. Like I said, I was doing it today, 2nd hour and 5th hour. I came up with some solutions. We've already done this one, I believe. It says if f of x equals 5 plus 3 times x minus 1 to the 2/3. Don't write the whole problem down because it's in your textbook. I just took a copy of it. And then show that f of 0 equals f of 2, but there isn't a value c that equals 0 in the open interval 0 to 2. We just had a question like this. Why doesn't this contradict Rolle's theorem? What's the reason? I think we had this yesterday. We had a follow-up question just like today in homework. Right, it's not differentiable on the entire open interval. In fact, the derivative doesn't exist when x is 1. Okay? So, you know, I'm kind of lost here where my other one is. Anyway, the function is not differentiable. That's why it doesn't contradict it. You can put in 0 and you'll get out, you know, whatever that is, 8. Put in 2 and you'll get out 8. So f of 0 equals 8, which equals f of 2. That's not difficult to show. Then the derivative doesn't equal 0 because you're going to have that negative exponent. Okay, I'm not going to go through that because we're running a little late on time, but there's some other ones I will go through instead. I don't know why the screen print keeps coming up, but hopefully it's not going to be an issue later on. Correct. Right, in Rolle's theorem. Now this one, we've kind of talked about before, the family of functions. If f is a quadratic function on a closed interval, prove that there's one number c in that interval that satisfies the conclusion of the mean value theorem. Again, this is in your homework. It's number 20 whatever, or 30 whatever. 30? All right, so if you have a quadratic function, what's the derivative going to be? A linear function. And in the mean value theorem, you can take that derivative. I just picked ax squared plus bx plus c, typical quadratic. And And the derivative is just 2ax plus b. The sooner you get away from thinking about numbers and thinking about ideas and concepts, that's what's supposed to solidify this topic. Hopefully that will work. If not, anyway, if you have a linear function that's not a constant, how many times will it cross the x-axis? Once. So it'll take on every value that equals y. So here is the mean value theorem we just had in the team relay. If you solve that equation, that's a linear equation. If you solve it, you're going to get how many answers? 1. And that's what this is. Prove that there's one number in the interval such that this satisfies the conclusion of the mean value theorem. You know, I would just get a little arrogant and say, when solving a linear function, there's exactly one solution. That's how to use definitions and ideas in tackling these problems. But if you can tackle these problems, my hope is it makes the algebraic problems a little easier. Okay, any questions on that one? Yeah. No, those are just the standard coefficients of any. I could have picked D, E, and F or whatever, but it doesn't have to be on the closed interval. Okay? Those A's and B's are different from a different idea, different definition. I think there's a really fun one coming up here at the end. This isn't it, but this is more of a thinking one. If f is continuous on the closed interval a to b, and the derivative equals c for every x in a to b, prove that f of x equals cx plus d for some real number d. It might sound a lot of gibberish to you, but if f prime of x equals c, that means it equals some number, correct? What type of functions, when you take the derivative, equal just a number? What did you say? Yeah, a line, a linear function. Okay? And you want the answer to be f of x equals cx plus d. That's what you want the answer to be. How can you work backwards and make this into the mean value theorem? How can you take this part right here and work it backwards into the mean value theorem? You remember the mean value theorem? F of b minus f of a equals f prime of x times b minus a. First of all, what letter do you have to get rid of so you have f of x by itself? This is a value. The x is a value. X is equaling what letter in this whole problem? Oh, we know this is equal to what? C. So that's not a problem. So what letter in this blue line of work has to equal x? The A or the B? If you take C times B and C times A, you have CB minus CA. Which one looks more like the CX part you need? The CB looks like that, right? And if you have x right here, all of a sudden you have f of x, don't you? If you let b equal x, you're close to that. You're very close to it, yeah?
It's not A because it's got that negative.
Yeah, it's not A because it's got the negative in front of it. And this has a positive sign in front of it like this one does. And this has a positive sign in front of it like CX. So if you change this definition to anything from A to X, you're close. So while it looks like a bunch of gibberish, it's actually a very calculated problem that gives you the answer on how to start. You can replace the B's with X's and work it out. So that's what this next one says. It says, okay, let x be in the interval from A to B. In other words, this is a fancy way of saying x is taking B's spot. Okay? X can't equal A. Do you see that with the parentheses? But x can equal B because it has a bracket. Okay? And then I just rewrote the mean value theorem. You don't have to do anything earth-shattering. You just have to find the starting point and write the answer that's asking for. Well, now all you have to do is distribute the C, correct? And then add over the f of a. And when you do that, you have the 2/3 of your answer. You have the f of x and you have the cx. What's the rest of this going to be? The ca plus f of a. What is that going to be? That whole thing is going to be d. And then you're done. These problems used to cause a lot of heartache for our study group. We never did really figure out every single one, but we started getting better at it. We started realizing it was like a puzzle. They gave you the answer, they gave you the beginning, you had to figure out which theorem to use. In this case, it tells you use the mean value theorem in the directions. That just becomes your plain letter D. D is just a constant, that's all that is, that's just a constant. So you just write, there, that's my answer. Cx plus D, and D equals all that other stuff at the end. Because it's not a variable, it's not changing, that's what D is a constant. Okay? Ooh, should we take a brain break for the tough one? Yeah.
Where do you get these, like, that E thing? Where do you get all the symbols and stuff?
Oh, I insert equations.
Like, how do you, like,
Insert equation, then there's a template.
is it like a special program?
No, Microsoft Word. Yeah. No, it's actually not symbols, it's insert equation, or insert object, and I go to the equation. Okay? Insert object, and it's an equation. All right, this brain break is going to be hard. I've had 2 people go 4 for 4. I've had 3 people go 3 for 4 on the left side, 3 people go 3 for 4 on the right side. So, depending on where you fall, I have no idea, but it's just an oddity. And most people go 2 for 4. Okay? So go ahead and stand up. You do not need a partner for this. This is one that somebody, actually I was just walking down the hall today and somebody said, try this one. So okay, I'll give it a shot. So, take your left foot and pick it up off the floor and turn it clockwise. And take your right hand and turn it counterclockwise. This is the first one. Can you do that?
Yep.
Jolie, all right? Good. All right, go ahead and get your balance back down. How many people did that one? Raise your hand. Fantastic. All but one person. So go ahead and take your right hand, right foot, and go clockwise. And take your left hand and go counterclockwise. Some people are falling. That's okay if you need to get your balance. Some people have their eyes closed. Interesting. All right, go ahead and put your feet down. How many people are 2 for 2? I'm 2 for 2. All right, good. One person's 0 for 2. All right. Anyway, take your left foot, go back to being clockwise again. And now take your left hand and go counterclockwise. Left foot, left hand. I can't do the left foot. All right, hands down. How many people got that one? Kind of? All right, good. Now, go ahead and do the right foot clockwise and the right hand counterclockwise. I can do this one pretty easy. I must be... It's all right? You're okay. This one I can do really easy. All right, how many people got that one? Good. How many people went 4 for 4? Not bad. How many people went 3 for 4 on the right side? And 3 for 4 on the left side? Good. Have a seat. Who was? What? Yeah, we did the opposite. Okay. Yeah.
Rotate your right foot clockwise and then try to draw 6 in the air.
No, I've never tried that.
Try it.
Well, I won't try it now. I'll have to practice, of course.
No, just try it.
No, we're good.
Bring it.
All right. So that one, I was just walking down the hall today and somebody said, try it. I said, okay, I'll do that. All right. This is the last one. This is the coup de grace, the final question. Ready? On 42, it says graph on the same coordinate axis Well, I think this question, if you can read it, you can do it. I'm going to show you the most efficient way of doing it. It says graph this on the same coordinate axis, y equals f of x between 0 and 1. So there's my domain, there's my window. 0 for the x min, 1, and y scale. And the line through, we won't worry about the line, but these are my y values I used. Y minimum, y maximum, y scale. 0, 2, and 1. After, I'll be honest, after the second attempt, that was my picture. I knew my first attempt was wrong because I had the parentheses here, I had the parentheses here, and I had them right here. I forgot the calculator automatically put this one in, so I needed another one right there. That was my first mistake. So that's how it's going to look like if you put in your TI. All these extra parentheses you're going to have because of the trig functions having an automatic grouping symbol. So it is pi x. It's number 42 in your text. So go ahead and type that out. Make sure, obviously, you're in radian mode. Now that you're in radian mode, this is what I came up with using that view screen. Yes? We'll go to the error. Okay. So I have 0 is my y minimum, 2 is my y maximum, 1 is my y scale. Why? The textbook picked from 0 to 1 for the x's. And once I graphed out the first time, I saw that this looked like a pretty good viewing window. Yep.
Okay.
Yeah, it looks all. Oh, there's a plus sign in between the sine and the cosine. So I can insert plus. I think now that's going to go up. Okay. I just put this plus sign right in here. All right, so far so good. Everybody had this picture. It says, end the line through these points. On your homework, all you're going to do is you're going to take that graph and you're going to draw the line through it. This is just like the one you did on problem number 1 and 2 to start it off, except this is a little bit more high level. If you took that red line and slit it to where it was tangent instead of a secant, it looks like you'd have, a point somewhere over here. It looks like you have a point somewhere over here where they would be the same, only tangent, and have the same slope, which is the mean value theorem. The mean value theorem says on the average rate of change, if the function is continuous and differentiable, there's a point that has the same derivative value as the average rate of change. Now I sat there for a few minutes. I thought, what's the best way of doing this? Because it says, use the graph to estimate on the calculator the conclusion. And I looked, I thought, is there a way to draw the tangent and just kind of like eyeball this? And then I came up with no. And I remembered everything the calculator does. So I decided to go ahead and show you everything I think it does that can do this problem. The directions say use it, so we're going to use it. First of all, I used the average rate of change. See how I typed in at the home screen f of b minus f of 0 all over b minus 0? We've talked about function notation before. I've got that big long expression typed into y1, so I thought, why not use it? All I did was I took f of b minus f of a all over b minus a, and I grouped it with another set of parentheses here and here. So I used y1 of 1 minus y1 of 0. Bars. Yep. VARs right below the left cursor arrow. Right next to the directional arrows. then go to y bars, then go to function. Right. The only reason I put 1 minus 0 is in case you want to scroll back and change these to like 3 and 5 or whatever. But I just typed it in, I got the value of the average rate of change. That's the slope, isn't it? Okay? I mean, you could have done the same thing by going to function, calculate, and then written everything down and subtracted. I don't want to do that. I want to be able just to get the answer. Yeah. Kind of a increasing graph with one vertex, I believe. Something like that. Okay. So now I have this. So that's the f of b minus f of a all over b minus a. And that has to equal what? The derivative. So I thought to myself, I know that if I put in y2 as a slope, and I've already showed you how the calculator can do the numerical derivative. That day we had the bubble, and that day we had the thick line, and they were like intersecting, and then I got really mad, and we like shut class down right then and there. I think that was the incident with Orrin Pollard. Same day, yeah, that was the same day. So I've already showed you this once, the numerical derivative. Yeah, this is under, well, y2 I just typed in 1.1162, you know, from the answer. Then y3 I got from the graphing screen. So you go to y3, you go to math. I think it's option number 8. Scroll down. No, what is it? Option number, oh, 8. Okay, I was looking upside down. And then you have to type in your equation, which is y1. You have to type in your lower bound, which is x, and your upper bound, which is also x. Actually, I'm sorry. You have to type in your equation, your variable, and your value. Also, notice one small but very important thing. I took my cursor up, and I shut off a graph of y1 by hitting the equal sign and turning it off. So I shut this graph off. I'm just using it. Okay? I'm just using this. So the only thing that's going to show up is a flat line and all these values between 0 and 1. Truly a paperless problem and a very high-level problem in the calculator. Now all I have to do is what? To solve the question, I have to find out where those two are the same, right? Yeah, so take your, then you find the intersect. Yeah, keep the same window because you're looking for all the x's from 0 to 1. Yeah, it is, because it's calculating every numerical derivative for this problem between 0 and 1. Look at the derivative you have to take. You have to take that derivative and then put in 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, you know, all these numbers and calculate and plot it.
Which one?
This one, oh, see, I shut that graph off.
How do you do that?
I went up to the equal sign, and I pressed enter. Yeah, there's 2 of them.
It's not good. I have an error in the first part.
That's because that's a minus, not a negative.
Oh, I thought I had a minus.
There you go.
All right, and then just plug that into that too.
Yeah. So now you just do the intersect. See, my graph, I don't have the big number 1 because I hit the equal sign and I shut it off. I'm still using it to calculate values. I just don't want to see the values being calculated. I think that's the first time you've had a complex screen like this for one problem. Y bars, then function, then y1. Well, y's are the same, and I want the x values. Okay? Love that problem. That's my new favorite problem of the day. Okay? All right, so far so good? All right, we're coming down the home stretch. Any more questions on this? Sure. Well, it's 42 in your book. Numerical derivative. Math, then 8. You go to calculus screen. The calculus. What mode are you in?
Solver? What's solver? What's solver? Whoa.
There's calculus for you.
Yeah, I went to that.
What is solver, Grant?
Seconds. Calculus. Numerical derivative.
Okay.
Solver.
Oh, it solves certain things, problems. We don't use that a whole lot. It's hard to type it in. You can't read things because it shortens the screen. I've used it before, but it's on like very narrow problems. Huh? Yeah, you need both answers.
What is the answer?
The answer is the x values. Okay? Because it says solve for x. All right. So, for 3 things, what's one thing that you or I or anybody needs to remember from today?
We learned how to do them.
Oh, first of all, the extra credit. And kudos to Jake. He did not lose his temper. He just kind of, I wasn't foreseeing this, but he just kind of lifted his hands up and let Audra just take whatever answer she wanted. He said, that's fine with me.
No, he
Oh, nice, good.
no, like solving a linear function is only one solution.
Yeah.
Okay. Solving a linear function, one solution. You don't have to. Yeah. Okay. I'll be right there. And try. Don't give up. Okay? Oh, I got to go. It's time to shut this off. I got to go answer a question. I got to turn the mic off because I have a very important meeting next hour. Yeah. The odds.
The word problems?
Huh? Yeah. 27, 35, and 41. And I'm going to shut off the microphone.